Hello and welcome to ch03b Statistics. I am Dr. Harris Tahir. In this video, I will present to you the second half of Chapter 3. In Chapter 1, we talked about the two distinct branches of statistics, the descriptive statistics and the inferential statistics. In the first half of this chapter, we talked about the two distinct sides or branches of the descriptive statistics. Measures of central tendency, which find out where the middle of the data is, and measures of variability, which show how much of a spread or how much of a variance or how much of a variability there is in the data set. Both of these two types of measures are very important for descriptive statistics. When it comes to measures of variability, there are three different measures of variability. There's range, and this is a measurement that relies on only two observations, the highest and the lowest. So the range is highest minus the lowest. A variance and standard deviation. So let's explore these measures of variability. The simplest measure of variability is range. The only benefit for this measure is that it's very simple to calculate, but it doesn't tell you much. Basically, is the difference between the highest value and the lowest value. So you see that this example, you're looking at all these values from 1 through 13, and the range is the highest minus the lowest, which is 13 minus 1 equals 12. The major disadvantage of range as a measure is that it can be affected by unusually large and unusually small values or outliers, because the number or the measure is only based on two numbers, the highest value and the lowest value. The only advantage to the range is that it's easy to calculate. Variance and standard deviation play a vital role in descriptive statistics. Standard deviation and variance, they both tell you how reliable the mean is, how much variability there is in the data. The higher the amount of variability in a data, the less reliable the mean. So how do we calculate standard deviation? Standard deviation is calculated with this formula. This formula is the formula for variance. And variance is summation x minus x bar squared divided by n minus 1, and that is the sample variance. So what you do is basically you take each value and you subtract that value from the mean of the data. So we have a data here that goes from 4 through 18. There are total 10 observations. If you add them all together and divide it by 8, you get a mean of 10. So now you take each value and subtract it from the mean and square each value. And then through a summation function, you add it all up. And you divide it by the n minus the 1. So n is 8, and you subtract 1 from it, and you get 7. For the numerator, once you get the total, you come up with 130. You divide that by n minus 1, and you come up with 18.571. Now, through this method, we can easily get to standard deviation, because standard deviation is the square root of variance. So the notation for standard deviation is S, and the notation for variance is S squared. If anything is squared and you want to get it by itself, you just get the square root of it. So if we use the same example, we have a variance of 18.571. All we got to do is get the square root of that, and we get to 4.301. For population, the notation is sigma. Sigma squared is your variance. The formula is pretty much identical, except for, notice the change in the denominator. It's not n minus 1, it is n. And the square root of variance gives you standard deviation. So there are two ways to get this. One way is the shortcut formula, which I don't recommend. The other one is the direct formula, which is used more often. So standard deviation tells you consistency. It tells you variability, how much variability there is in a data set. Are the values closer to the mean, or they're far away from the mean? Standard deviation tells you the average distance of each observation from its mean. The average distance of each observation from its mean. Coefficient of variation puts mean and standard deviation in perspective. Coefficient of variation tells us what percentage is standard deviation of the mean. The higher the percentage standard deviation is of the mean, the higher amount of variability that you see in a data set. So a high coefficient of variation shows high variability, whereas a low coefficient of variation shows low variability. So simple formula for coefficient of variation for sample is the standard deviation of a sample divided by the mean times 100. For a population, it is the standard deviation of a population divided by the mean of the population times 100. So now in this example, you can put things in perspective. Stock A had an average price of 50 overall for the whole year. So you took the stock price of each day and divided it by how many trading days we had. The standard deviation of this stock is 4, so the coefficient of variation is 8%. Stock B had an average price of 100 and a standard deviation of 5, which gives us 5% coefficient of variation. So that out of these two stocks, the stock A has more variation, so stock A is less consistent than stock B. So the prices throughout the whole year for stock B were closer together to the mean compared to stock A, where the values were on an average farther away from them. The concept of z-score is a very important concept in descriptive statistics. It identifies how many standard deviations a particular value is from the mean. So if you have a z-score of 0, that means that you're at the mean. Positive values of z-score shows that you are on the positive side of the mean, and negative values show the negative side of the mean. The z-scores range between -1 and +1. So this is a formula for calculating z-score. It's x minus the mean divided by the standard deviation, and x is the data value that you want to look at. Where is that data value relative to the mean and standard deviation? So you can calculate z-scores for different restaurants here. So for example, this is an example of a Burger King. So the Burger King calories subtracted by the overall mean calories divided by the standard deviation of those calories give you a z-score of negative 0.276. Means that the Burger King is below that average on the left side of it by negative 0.276. The empirical rule plays a very important role in statistics. Empirical rule says that 68% of your observation for a bell-shaped symmetrical curve and a normal distribution, 68% of the observations are going to be plus and minus 1 standard deviation from the mean. 95% of these observations are going to be plus and minus 2 standard deviations of the mean. Literally all of the observations are going to exist within 3 standard deviations of the mean. Empirical rule is, if we rank top 3 theories in statistics, empirical rule would be one of them. So you can solve z-scores in terms of x. And here are the formulas. If you wanted to find out a particular x, you can take the mean and times that by the z-score times the standard deviation. Same for the sample as well. Chebyshev's theorem applies to the distributions that are not normally distributed. They are either left skewed or right skewed distributions. And according to this theorem, for that shape, regardless of the shape, means that it could be normal or not normal, skewed left or right. 75% of the data values would be within 2 standard deviations, 89% within 3 standard deviations, and 94% within 4 standard deviations. That concludes the second half of chapter 3. In this second half of chapter 3, we talked about measures of variability. These measures of variability show us how dispersed the data is, how far apart the values are, and how far apart the values are from the mean. We talked about the range, standard deviation, variance, coefficient of variation, and then the empirical rule, which applies to normal distributions, and then finally the Chebyshev's theorem.